We started with a stock solution of copper amine with a 0.02 molar concentration. After making 3 dilutions from this concentration, we will measure the absorbance of each dilution by using a spectrophotometer. The spectrophotometer works by shining a light through a solution, while a detector on the other side gathers how much light was absorbed.
Using a pipette, each solution is poured into a cuvette, a container that we will use for the spectrophotometer. One of the cuvettes is filled with water, which is called our blank. Our blank will be used to negate the effects of the water molecules so we can get a clear reading. If we fail to use the blank, we will get an incorrect absorbance value because the water molecules will have absorbed light.
Based on what the spec tells us, we can also use the absorbance value we'll gather to determine the concentration of substance. Concentration and absorption are proportional as defined by Beer-Lambert's law. Beer-Lambert's law is stated by the equation absorbance equals the product of molar absorptivity, the length of light path, and the concentration. The relationship is linear, which we'll graph later.
First, we will use our blank to negate the effect of any water molecules. We will wipe down 2 sides of the cuvette with a Chem wipe in order to remove any other particles that might interfere with the absorbance reading. These 2 sides are the sides that will face the light and the detector. Place the blank inside the spectrophotometer pointing towards you. Close the door and select 0, negating the effect of the water molecules. The value in the left-hand corner becomes 0. Now that we have run through our blank, it's time to measure the absorbance of each dilution.
Taking our first dilution, we wipe down 2 sides of the cuvette. Once we've placed it in the spectrophotometer and closed the door, we click Read. In the left-hand corner of the screen, we see the absorbance value for that dilution. Now, we repeat these steps for each dilution.
We determine the proper wavelength to measure absorbance by scanning across all wavelengths using our stock solution. We do this for 2 reasons. 1, to find the lambda max, which is the peak wavelength at which the solution's photons absorb the most light. 2, to determine how accurate our selected wavelength is.
Now, we have all of our absorbance values.
We will now make a graph using our absorbance and concentration. Because they are proportional to each other, they are also linear, so we can use the equation y equals mx plus b. Absorbance is our y-axis and concentration is our x-axis. Plugging in all of our values gives us this relationship. We can also use this graph to find concentration if need be.
Now that we have finished our graph and using the spectrophotometer, it's time to clean up.